Hi everyone, welcome back to the channel. So we are going to discuss another problem from our SD sheet since we have started dynamic programming. This is the next lecture that we are going to have. The problem is longest increasing subsequence. Give me a moment, I'll just check if we are live. Seems we are live. Okay, so let me explain you what does this question ask us to do. So you are given an array of integers. Find the length of strictly increasing subsequence, which is the longest. I'll tell you what we actually need. Let me just take this test case and then I'll explain. I hope you already know what is a subsequence. Even if you don't, I'll tell you. We already discussed about substring. So the last question that we did was based on substring. This one is a subsequence. So let's understand what is the difference. So what you have to do here is you have to find the length of the longest subsequence from this given array. First of all, subsequence is anything. It is, why is this not working? One second. Give me a minute, guys. It's working. Okay, let's start. So subsequence is a series of integers from this given array which need not to be continuous, and it has to be strictly increasing. So find such a series in this given array which has integers in the increasing order, and the length of such series should be the longest. So what, I'll take a smaller example so that you can understand. 1 0 2 3 and let's take 4 5. For example, this is one array of integers that is given to me. We know we can find multiple increasing subsequences. If I take 1, then 4 and then 5, I will have one subsequence with strictly increasing integers, right? If I take 1 and 3, right, 1 3 and 5, then also it's strictly increasing. If I take just 1 and 5, I'm just writing the possible increasing subsequences. If I start with 4, then I can have 4 5. If I start with 0, I can have 0 2 3 5. So these are not all, but these are few of the subsequences which are strictly increasing in nature. But from this example, which is the subsequence with the maximum length having all the increasing integers? So we can see that we have found this one so far. Is it possible to get any other subsequence who has a length greater than this length 4? No, it's not possible for this case. The length of 4 is going to be the maximum for this test case. Okay, so how are you going to solve this? Are you going to find the subsequence for the entire array and then calculate which one is the longest? This is one way. Now if you are going to go and find number of subsequences, how much time it will take? Obviously we are not going to do with that, but for example, you first iterate over all the integers, all the numbers of this array, and then you check what are the increasing numbers, right? You try to form one subsequence with this number, then you form a subsequence with this number, then with this. So all together you will realize that it will be very high complexity task to find the subsequence in the first place, right? Now if not this, what is the second thing we can do? Let us go in the recursion tree. Let's try to understand how recursively also this thing can be thought of. So if I take an example, for example, I have this one for, let me take a even smaller example. For example, I have 1, 2, 0 and 3. Okay, so see, if I have two options for every number in order to obtain a subsequence, whether I include this number, even I include or I don't, it's not like I'm not going to get a subsequence. The minimum subsequence would be anyway of length 1. Why? Because every integer in itself is also a subsequence of length 1, so it can always be an answer. But the point is whether to include it or not. If I include it, there will be some changes in the pattern in how I am going to take the next number. For example, if I don't take 1, there is a possibility to start a subsequence with 0, right? And maybe I get a bigger subsequence if I have not taken 1. Or if I take 1, what if I get a bigger subsequence by including 1? So all in all, we got two options for every number. That is, this is known as inclusion and exclusion property in recursion. We try to understand the recursion tree in a lot of questions while we are solving using dynamic programming by this method. So what it says that if I include 1, let's say, if I include 1, then what will be my subsequence? So the subsequence right now I get is 1. And if I don't include 1, I have the rest remaining numbers to form the subsequence. So right now my subsequence is empty. Now the next option is, now my iterator is here, whether I include 2 or I don't. So let's say if I include 2, and let's say if I don't include 2. If I include 2, is it possible to form a subsequence? Yes, because the last number was smaller than 2. I can definitely create a subsequence which is strictly increasing. And if I don't choose to take 2, I'll still have the subsequence with integer 1 in it. Now here also, if when I am at empty, here I did not choose 1, but I am at 2 right now. I have two options whether I take it or not. If I take, I'll get a subsequence with only 2 in it, and if I don't take, I'll still have an empty subsequence. Correct? Okay, moving to the next pointer, next iteration, which is the next integer. We have the decision whether to include 0 or not. In this subsequence, if I choose to take 0, can I first of all include 0 at the first place? Not at all. Why? Because the last number that I inserted was 2, and 2 is greater than 0. So I am not going to get an increasing subsequence. So it will remain 1, 2. I am showing you the subsequence, although what we have to keep track is the length of that subsequence. So far I have gotten 2 as the largest length of my subsequence. If I don't choose to add 0, anyway the subsequence is going to be this only. Here if I choose 2 in 1, the subsequence I'll get is 1 and 2, right? Because I chose to take 2 and the last integer was 1. I can definitely add 2 here and I get a subsequence of 1, 2, and in another case if I don't choose, my subsequence still will remain 1. Here let's see, if I choose to add, what is this? I was at 2, right? That makes, sorry, I was checking for 0, not 2. My mistake. The iterator was at index which points to 0. So if I choose to take 0 here, I will not be able to form a subsequence which will be strictly increasing. So anyway, taking or not taking is not going to affect my answer. My subsequence will be just with integer 1. Here also if I choose to take 0 and even if I don't, the subsequence will remain 2. This in empty substring, if I choose to take 0, I am going to get a new subsequence, wherever I said substring, please replace it with subsequence. It was my mistake. So here I'll get a subsequence with integer 0 in it, right? So we are done with all the possibilities of including and not excluding zeros, right? So as you can see, as in when we are progressing towards this recursion tree, every node has two options whether to include or not, right? Now we are at the next index which is pointing to 3. So here if I choose to take 3, can I create a subsequence which is strictly increasing? Yes, I'll get 1, 2, 3. If I choose not to take 3, I'll still be at 1, 2. Here in 1, 2, if I choose again, since you know that recursion, when we make recursive calls, right, in recursion tree, you can clearly see that the reason we move to dynamic programming approach is that there are lots of repetitive sub problems that we keep solving again and again. Here also we had this case, here also I am having this case. So due to these overlapping sub problems, the time complexity increases. I am going to evaluate whether to include 3 here also and I did it here also. There is no point of adding into my time complexity. This is the reason we move to DP. We'll see how that will work. So again, I'm going to get 1, 2, 3, and if not included, 1, 2. Here if I include 3, definitely I'll get a new subsequence which will be of length 1, 3. Here also when I include it, I'll get this 1, 3, and if not included, it will remain 1, 1 only, right? 1, 1. Fine. Talking about this 2, if I include it, I'm going to get 2, 3, and if I don't include it, I'm going to get 2. Talking about this 0, there are two cases, including and not including. So if I include, I'll get 0, 3, and if I don't include, I'll get 0. So far the maximum length I got is of length 3. So this is what I will return. I'll return the length, right? I just showed you this recursion tree because I feel before we move to the DP approach, it's important that you understand what was the reason that we moved to that approach. So talking about its time complexity, if you see for every integer we have two options, whether I include it or not. So 2 for this, 2 options for this, 2 for this, 2 for this. So 2 multiplied by how many times? Multiplied by how many times the length of your array. So that comes out to be 2 to the power of n. So 2 into 2 into 2 n times, it will be 2 to the power of n, right? So big O of 2 to the power n will be your time complexity if we go recursive way, right? So how are we going to reduce it? By using an extra, again as I told you, DP is just about making use of the answers you got from your previous calculations and generating the new answer for the new case that you are at. The only difference is in recursion also we were dependent on the previous answers to generate the new answer, but we were repeating a lot of cases here for the same answers. So DP just minimizes that by taking a structured data structure. Here we are going to use array, which will be storing my previous answers. Now let's understand it, how it's going to help us using that. Let me write the test case. It's very big, I'll write a smaller one. For example, I have this array 5, 8, 3, 7, 9, 1, right? And fine. Now let's see it how. I am going to take an extra array of same length as the given array, and let's name it LIS, longest increasing subsequence. Since I told you every number in itself, if I take a subsequence of length 1, any subsequence of length 1 will anyway give me the length of 1 in the worst case also, right? Because one integer itself is also subsequence. So I will pre-fill this array with 1 at all the indexes, which tells me in the worst case scenario, even if I'm not getting an increasing subsequence, at least one subsequence I'm going to get, which is the number itself, right? Okay. Now let's do one thing. Let's iterate over this array in this way. My I starts here and my j goes from 0 till I minus 1. How and why? See, when I am at this index, okay, I'll check, is my ARR of j, this ARR of j, is it less than ARR of I? If this is the case, right, then I can definitely include it into my answer. That is the length of generating this longest increasing subsequence. If I add 5, 8 after 5, this is a subsequence I am going to get. And what will be the length? So its length will be the length that I have in my LIS, right? See, LIS is telling the maximum length of subsequence you will have till that particular index, right? So right now it tells me that if I just have 5, I have the LIS, longest increasing subsequence of length 5. If I want to include 8, obviously one length for 8 will be increased to the length of subsequence that till 5 I was getting. So I'll get that answer from LIS of j. Okay, I'll add 1 to it, 1 plus LIS of j, and that will be stored in LIS of I. But actually I have to calculate, is it the maximum of what was already stored? If so, I will add it. So I'll compare max of 1 plus LISJ, comma, the original value at that index that was present. If it will be greater, I'll be replacing it. So right now, this is what I have generated. Don't be confused. Once I do the dry run, you'll understand. So 8 is greater than 5. what is the value of LIS at J? 1. So I add myself to it and the 1 plus 1 becomes 2, right? I move my I to the next index. J starts from 0 again. I check, is my ARR of J, is my ARR of I, this is my array, right? ARR of I greater than ARR of J? No, not. So definitely I cannot include it to be as a longest increasing subsequence because it's not increasing in the first place. So what do? You do nothing, you move to the next, you try and move your J to the next index, right? Unless you reach I minus 1th index. Again, when you commit this condition, it fails. So no more iterations. Basically there are 2 loops running. Now I moves to the next index and J comes back to the 0th index. J is back at 0th index. Start your comparison again. Is 7 greater than 5? Check this. Yes, it is. So LIS and this 3 remains 1 only. When you are here, you compare what is the value at LIS of J. It's 1. So you add yourself. So length will be increased by 1. 1 plus 1, it will become 2. Move your J to the next index. This tells me that I have formed a subsequence with 5 and 7 so far. Now you are at J is at 8. The condition fails. A subsequence cannot be formed, which is longest increasing at the first place. Now J moves here. Can you form a subsequence from this condition? True, I can. Now what will be the length? Is it greater than the existing length? Yes, because it is forming a subsequence which looks like this, 3 followed by 7. So earlier the length at LIS of I, that is the index of 7, was 1. That was for 7 itself. Now it will be counting for 3, 7. So the answer will be what is present at LIS of J? 3. So you add yourself, it becomes 2, right? Let me just write. Okay, fine. Now can I move J further? No. Move your I to the next index. Move your J back to the 0th index. Check. Is 9 greater than 5? Yes, it is. So I can get a subsequence which looks like this and the length will be given to me by adding 1 to the length of LIS of 5. Means LIS of 0th index. So 1 plus 1, 2 is greater than what is currently present at, I am at 9, no. So currently the 9 is means 9 has this value 2 at its LIS. That means, but when did I take 9? I'm wondering. One second, I think we formed 3, 7, we made it 2. When did I make 2 here? 7, 9. I think it's a mistake, it should be 1. I have not yet updated this one. It is 1 only. Okay. So I compare it, I make it 2 because I can form a subsequence which looks like this. Move your J to the next index. J is here. Compare it with 8 and 9. So you see that the LIS of 8 is 2 and 9 is greater than 8 for sure. You can add a subsequence after 8 which looks like this. But actually LIS of this index already gives me 2, which tells me that 8 itself has been added to some number which is a subsequence 5, which is basically 8 is following 5. This is a subsequence whose count has been written here, right? So if I add 9 to it, I can definitely get my subsequence, an increasing subsequence, and the length of it will be the length I got till 8, right? That will be given to me by LIS of this index, and I add 1 to it and compare, is it greater than this value, current value? Yes. So this 2 will be replaced with 3. Move your J to the next index. What is the, yes, 9 is greater than 3, but LIS of 3 is 1. Even if you add yourself, that will become 2. 2 is not going to exceed this value 3 which is at 9. So you're not going to get a bigger subsequence. Move your J to the next pointer. Even if you add 9 after this 7, so 7 is already forming a subsequence of length 2. You add yourself to it, the length will be 3, 7, 9. This is a subsequence that it will create, but it will not exceed the length it already has. 3, 3 both are equal, so no point of updating. Okay, now you move your I to the next index. Start your iteration of J from 0 again. You will see that this will remain 1 only because 1 is not greater than any of the values it has before it. So finally you check, and while you are filling up the values in LIS, okay, you can keep a track of the maximum answer that you have found so far. So you will see that 3 is what tells me that this is the length of the longest increasing subsequence, right? So that is all about it. Although we have reduced this time complexity from big O of 2 to the power n to now typically big O of n square. Actually, you can see that for every iteration I am moving till I minus 1th index. So all in all it will be big O of n square, although it can also be further optimized by using binary search, which kind of brings your time complexity to n log n, I guess. I'll have to check exactly what it is, but it will be less than big O of n square. Since the intent of this problem was to help you understand the dynamic programming approach, so the solution that we discussed, I will write it here for you, but it will not pass all the cases. 2 cases it will fail because they are expecting you to solve this problem in n log n of time complexity, and the DP approach is definitely bigger than this. So this compiler will not accept your solution. On the contrary, if you use the same solution in lead code, it will accept. So that is just for you to be sure that the approach that we are using is correct and the solution is also correct. It's just that the demand of this question is to further optimize it. Okay, but you need to know DP approach as well. So I'll just quickly write this DP approach for you all. Okay, so that you all can understand. So let's take int lis equal new int, what is the length, size. Okay, for let's take an int answer equal to 0. So answer will initialize it to 1. Reason being, you know that the minimum subsequence will be of length 1 by taking just one integer also from the array. It will be the minimum answer. And let's fill arrays dot fill this lis by 1. That means I am pre-filling this array with 1 everywhere. That tells me the answer, minimum answer possible. At least one length of subsequence is what you are going to get. So int I equal to 0 will start from 1, I is less than n, size, and I plus plus, right? You take the next loop starting from j equal to 0 till j is less than I and j plus plus, right? You check if your ARR, let me make it ARR, if your ARR of I is greater than ARR of j, that means it can form a subsequence. But is it the greatest one? Is it the greater one? That I'll check from lis. I'll update lis of I with math dot max of what is currently present there and compare it with 1, adding yourself to what was the length at lis of j, right? That's what we wrote, 1 plus lis of j, compare it with lis of I, right? Okay, and simultaneously I'm keeping a track of maximum length that I've gotten in lis, because that will be my answer. Math dot max of, you update answer with answer and lis of I. Fine, is that right? Answer equal to answer lis, right? Then you come out of the loops and you return your answer. Let us check. It will show you TLE. Yeah, so I think five test cases did not pass because they're expecting you to do it in log n. Now for just to assure, I just paste this same solution in this lead code problem, and let me make few changes. This nums I'll convert to array because you have used ARR, and their size was already given in your function. I'll just define it here, int size equal ARR dot length. Okay, let's see. Fine, so this is an accepted solution here. I hope you all understood the problem. Let me just check if you guys have any doubts. I'll just check. If not, we will wrap it up. Fine then, that was all for today everyone, and see you all in